Tangent response analysis using Laplace transform function. Anna University syllabus, that is Unit 3. I taken at Man Engineering latest classes at 2026 year. Man, I welcomes you all. Circuit analysis, tangent response analysis using Laplace transform. Another name called time domain analysis. Problem. For the above circuit, determine I current in the 10 ohm resistor where the switch is closed at t is equal to 0. Assume the initial current through the inductor is 0. Switch is closed t equal to R is given. Determine current and L is given. Shown in circuit. Switch is closed and supply plus minus 5 ohm resistance between the two meshes. So consider mesh 1 and mesh 2. Mesh 1 current IN of t, mesh 2 current I2 of t. Using mesh matrix method for find out current. First, RL circuit formula, tangent response analysis formula is general formula is used. Or I of t plus L di of t divided by dt formula is equal to V of t. That formula is used. First, consider mesh 1, that is 20 volt supply and 5 ohm resistance. Current is IN of t. So, from the equations, apply KVL law. 20 is equal to 5 into resistance and IN of t, and I2 of t is opposite direction. So, minus 5 into I2 of t, that is 5 ohm resistance depends upon the current IN of t and I2 of t. So, first equation form, that is consider second mesh, that is consider 5 ohm and 10 ohm resistance and 2 Henry. We already know inductance how to write, that is write di2 of t divided by dt. So second equation is I1 is opposite direction. So minus 5 I1 of t plus 10 plus 5, that is I2 of t, plus 2 into inductance di to t divided by dt is equal to 0. We already know how to take differentiate. That is second equation. Taking Laplace transform. Taking Laplace transform, minus 5 take another side. Taking Laplace transform, first equation is 5 I1 of s minus 5 I2 of s is equal to 20 divided by s. Second equation is minus 5 I1 of s plus 15 I2 of s plus 2 into s I2 of s minus I of 0. That is second equation. Next take I of 0 as tends to 0. First equations is take I of s, put that is Laplace transform. So 5 I1 of s is equal to 5 I2 of is equal to minus of 20 divided by s, that is tends to first equations. The second equations take Laplace transform, minus 5 I1 of s plus 15 I2 of s plus 2 s I2 of s minus I of 0. Second equation, that 2 I2 of t divided by dt is formula is apply final value theorem. Second formula given in tabular column previous classes. L di of dt f of t is equal to s of f of s minus f of 0 plus formula is apply in take second equation for Laplace transform function. Next, take I of 0, that is current is 0 given in questions. So take current 0. Second equation is go to that format. Take form mesh equations. Mesh format. Form mesh. Using first and second equations form mesh matrix. That is 5 minus 5 minus 5, 2s plus 5. Sorry, 2s plus 15. I1 of s and I2 of s is equal to 20 divided by s0. Kindly note that first equation and second equation using form mesh matrix. 5 minus 5 minus 5, 2s plus 15. I1 of s, I2 of s, 20 divided by s0. Using mesh matrix method, find out I1 of s and I2 of. Only we want I2 of s value. Only we want I2 of s. So I2 of s obtained is 10 divided by s into s plus 5. Apply Gaussian fraction in I to s formula. 10 to the s to the s plus y split into a divided by s plus b to the s plus y. Find out a b value. A is 2, b is minus 2. Put in the format I to s is find out. Taking inverse Laplace transform formula. I already explained formula in previous classes. Apply Laplace e power minus at is 1 divided by s plus a. That is take inverse. Inverse formula is apply. I2 of 2t is 2 minus 2 e power minus 5. That is answer. That is tangent response analysis and using mesh method and Laplace transform method is applied in this circuit. And Laplace transform formula L di by dt f of t is f of s minus f of 0 plus apply L e per minus a t is 1 divided by s plus a is applied. And mesh format s mesh method is applied. Kindly use this video, that is tangent response analysis using Laplace transform and mesh method. I taken latest classes 2026 1 to 110. So kindly use this class at circuit and subject. Thank you.